Topic 2, and now we're getting into rational numbers as exponents. There is a relationship, and that's what we'll go over in just a moment. Now, I think we would all agree that what I have up here are numbers with exponents. But these exponents are in the form of fractions. Just what does that mean? Well, this is what we call fractional exponent notation. And they are related, believe it or not, to the radical. Now there's the radical sign. I'm going to take the base. The base becomes my radicand. The m becomes the exponent, and the n, which is the denominator of that fractional exponent, becomes our index number. So let's use this one here. So we're going to convert a fractional exponent to a radical expression. The 4 becomes our radicand. The numerator of the fraction becomes this exponent, and the index number is the denominator of that fraction. Now notice, if it's a 2, we don't write it. So again, radical base becomes our radicand. The numerator of our fraction becomes an exponent. Now again, if the exponent is 1, we don't write it. But our denominator is our index number. And that's what we'll be doing. And that's the relationship between fractional exponents and radical expressions. Okay, so let's work these out here and fill them in. Some of this is a review from earlier chapters, but let's take a look at this one. So this, in its regular form, is going to become 1 over a, and it's to the nth. That is, when the exponent crosses the division bar, the sign of the exponent changes. And this is going to be what we just demonstrated. I don't like when they do it this way. We should write it m over n. That way it's clear. So our radical sign, our base is a, and it's going to be to the m power, and our exponent is the denominator of that. And for number 3, we're just going to add these things. This becomes a, our base is the same, and it will be m plus n. Because we're multiplying, and we're multiplying by adding exponents. And this is, again, we're going to bring this up, subtract it from whatever's there, and we do it depending what needs to be done to get our exponents positive. Now in this case, here's the case where we're going to multiply them. And we see that in F over here. And then here, remember, there is a 1 by each one, and that gives us letter E. Okay, a good little review. Okay, here they want us to convert from fractional exponent form to a radical expression. So radical sign, a is our base, and this is 1/4. So 1 is our exponent, and our denominator is our index number. So this is going to be 1/3, 100, or 1,000 I should say, And again, radical expression, 1,000. Numerator is 1. Index number is 3. So this becomes the third root of 1,000 is 10. Now this is going to be, again, it's 1/2. So the radical sign, our base is P, Q, R. That's all to the first power, so we don't have to really write that. And our denominator here is our index number is a 2, and we don't write that. And this is going to be radical sign, our base, x to the third, y to the fourth becomes our radicand, and this is all to the first, but here we put the denominator is our index number. So again, I don't like the way they're showing this, but I guess that's the way they did it. So here, radical sign, our base becomes our radicand, and this is 5/3. The 3 becomes our index number, and often we put the 5 out there like that. That's the preferred way to show it. So now we take the third root of 8, which is 2, and we raise it to the 5th power. And 2 to the 5th is 32. So for this one, we're going to go radical sign, 36 c to the 6th. Now our index number, again, this is 3/2. Index number will be 2, so we don't write anything there. But we're all going to raise this now to the 3rd power. So we take the square root of 36, which is 6. The square root of this, remember we're just dividing that by 2, that index number, that becomes c to the 3rd. And we're going to raise that now. Remember, we're raising that to the 3rd power. So there's a 1 there. So this becomes 6 to the 3rd, c to the 9th. And 6 to the 3rd is 216. And those were the stages needed. Okay, now they have it in radical form. They want us to put it in exponential, fractional exponential notation. So our base then is the radicand, 10, and there's a 1 there, and this 1 goes in the numerator, and the index number goes in our denominator. And now this is x, and there's a 2 there, and there's a 7 there. Now they didn't ask us to simplify, but just that. So this is going to be a b to the 3rd. I'm going to put that in a parenthesis because this is just 1 unit right there, and in a sense there's a 1 out there, so 1 to the 4th. And here I can see it happening already. It's going to be 3m n to the 4th. That goes in a parenthesis. And then our exponent, our of 2, goes as a numerator there. our index number goes there. Okay, so it's important to realize the relationship between radical expressions and fractional notation. We're going to be using this skill here in just a few moments. Now, back, I believe, in Chapter 5, we went over this, that if you have a negative exponent of a fraction, you just take the reciprocal of that fraction, and that makes the exponent positive. So I did that. And now, forget about that. And this will be the third root of 27 raised to the second power. So the third root of 27 is 3. 3 squared is 9. And this one, to make it positive, all we're going to do is go 3x squared, bring the y up to the 4/5. Now another way of writing this would be 3x squared, and then put it in radical form with our index number of 5 there, and then y to the 4th. Both of these are actually they're the same. One's in fractional notation, the other's in radical form. So again, this will become a to the 2/3 up there. This is going to be 9 to the 1/2. This is going to be b to the 3/5. Now to put that in radical form, this is going to be the third root of a squared. And now the square root of 9 is 3, and that will be the 5th root of b to the 3rd. Now the answer key was giving answers in that first column here. I guess I caused them to disappear. Now on these next ones, what they're showing us is how to put this into a graphing calculator. Well, you take the radicand, put that in parentheses, use the caret sign on your calculator, and then in parentheses 1 divided by 4, because you're converting it from its radical form to its fractional exponential form. And this is what it looks like on the calculator screen. And the same here. Put the radicand in parentheses, caret, and this is to the 1/5 power. Okay, it looks a little bit like this. Again, I'm not sure they're going to use this in your course, but I had the calculator here and I'm playing around with it. And here they want you to practice putting this value into your calculator. Remember, the base then is this, which is the radicand, caret, parentheses, 1 divided by 4, so 20 to the 1/4 power. Then negative 35 caret to the 1/5 power. And these are your values to the nearest thousands. That is 3 decimal places. In number 25 now, we're going to multiply these. This is 3 to the 2/5, which I'm going to change to 4/10, and 1/10. And again, this is a technique for doing it. This then equals 3 to the 5/10, which is 3 to the 1/2, which is the square root of 3. Now they didn't want us to simplify, so this is an exact answer. Now here we're going to have 5 as our base. I'm going to move this up to the top. So this is, I'll put it as it is there, a negative 1/3. And this, when it comes up, becomes a positive 4/3. I got that wrong. 3/4. Better. Now, I need common denominators, so my common denominator will be a 12. So this becomes a negative 4/12 plus 9/12. So this eventually becomes 5 to the 5/12. And I believe that's how they want the answer. Yes. So notice, seeing the fractions written this way, it's sort of difficult to work with them. But if you put them in their proper form, we're multiplying here. So here we can cancel out. So this then becomes x to the 6/5. And I'll set this one up. So here, this is going to be a. Notice these cancel out, and I get a negative 1/5. I'm not finished with that yet. And this will be b, and that'll be a negative times a negative, so that gives me a positive 1/10. And to keep our exponents positive then, this becomes b to the 1/10 over a to the 1/5. And that should do it. Right, here we get to see how useful changing something from its radical form to its fractional exponent form helps in doing our calculation. So 15 is the numerator, 3 is our denominator. We've done this before. This gives me x to the 5th. We just do our division there. And then here we put our radicand as our base, and then our 3 as our numerator, the 6 is our denominator. This eventually simplifies to 1/2. So this then becomes the square root of CD. Anything to the half power is the square root. Now this one's a little tricky. Here we get m to the 1/5, and the square root is to the 1/2. So this is going to become m to the 1/10, and that becomes the 10th root of m. Now this, when we put it into its fractional form, 12 divided by 4 is what? This is going to be 3. So let's change that. But you all see where it came from. Oop. My pen's giving me a little problem. This is going to be a 3 here. Got to clean that up here. So this becomes now x to the 9th, y to the 6th. So the fractional exponents really help in simplifying some of these things that could be complex. Okay, well, that wraps this up. This was only 21 minutes.